see what you do. Are you going to do 1 first?
Yeah.
Okay. Tell everybody what you're doing.
So, number 1, you just, the simple way I did it was add 5 and 2, since it's the same base.
Same base, add the exponents, good.
So it'd be 7 power.
Right.
And then number 2 I got is, so I did because I just basically add that 11 because that helps me.
That helps a lot of people.
Because I always forget to add that. And then I just add them all up since they're the same base again. So 4, 5, 6, 7 over 5, 5. Is that it?
So read the directions now. What does it ask you to do?
Okay. And then simplify that. Then to see what goes in the right.
Well, think about it. How many y's are on top?
7 y.
And how many are on the bottom?
Oh, I know. Okay, I get it now. 2, 3, 4, 5, 6.
Squeeze one in on the left. Right, so your final answer, and they're in the numerator and the denominator?
Numerator, so it'd be y2 over y.
No, because all the y's canceled on the bottom.
Yeah.
So,
Y.
yeah, y to the second power, y squared. So, yes, in a minute. So what is the rule that you could have used now looking at that to make that quicker? Like right here,
Oh, you could have minus them.
you could have subtracted them because right here, right, when it's a product, you're adding. So when it's a quotient, you could have subtracted 7, take away 5 to get y squared. Okay, good. Sig, you want to come up? Sure, for number 3. Let's scroll down a little. Well, maybe more than just 3. 3's
I'll do 3 or 4.
okay.
Okay, well, 3, since these are both in parentheses.
Right?
Anything to the 0 power is just 1.
That's right.
It's just 1.
That's all the work.
Then, 10 to the negative third, it's 1 over 10 to the positive third.
Right. And now the directions aren't right as a single exponent. It's actually saying to simplify. So take
Right,
it
so
another
it's
step.
1
What's the value?
over 1,000.
Correct. 1 over 1,000. Perfect. Who wants to tackle number 5? Okay, Nadeed. Not ready? Is anybody ready for 5? Sandra, you want to try? A little more room.
Well, I had 2 to the second, but just equal 4.
Maybe work below the problem.
So 2 to the second would equal 4. 4 times 3 to the 4th, 9. So that's 9 plus 2.7. 9 to the 3.7. Have to do a little math here. I got right.
Is this the first time you've written on it?
Yeah.
Yeah, it's a little weird.
4 times 81.
Yeah, 4 times 81.
Times y to the 7, because I don't know what y equals.
Right.
Over negative 3 to the 5th times raised to 81. negative, I mean, since it's an odd, power that is just gonna be, negative still.
Right, you guys hear that? Since it's an odd power, it's still going to be negative. Can you see it now? Okay.
As far as I got.
Okay, so let's talk about, yeah, and you can go that way. I think we can make it easier for you.
Yes.
Should we make it easier? Has anybody thought of an easier way? Okay, let me try. So he's not wrong. Yeah, negative 3 to the 5th is we got negative 243, right? But let's see. Let's finish it. We know that 3 goes into 81 how many times?
20, 27.
Or better yet, like, I mean, we could do common factors. It's 3 to the 4th, right? What if we scroll down a little farther and think about, boy, this is a lot of work. Maybe we can do this easier and go back to his 4 and then do 3 to the 4th here and leave it like that for a minute. And this is y to the 7th and y to the 5th. And this is, we know because this is negative, in the end it's going to be a negative answer, but it's just going to be 3 to the 5th. How many 3's are on, keep going down to it, how many 3's are on the top?
Oh, that makes sense. It's 3 to 9.
So there's 4 3's on the top, right?
Yeah, there's 5 3's on the bottom.
So where is there going to be 3's left over? In the denominator, how many? 1. Yeah, so rewrite the top to be, so cancel 3 to the 4th. And that just becomes a 1. And in the denominator, what's left? What does that 3 to the 4th cancel with? Right, so that just becomes a 3. Do you guys see that? Isn't that easier than doing all that multiply? We're getting there. What's in the numerator now? 4.
Well, 4 times 1, 4. Easy.
No. So it's going to be,
I just erased the whole thing.
no, that's good. So we cross this out. We have a 3, so we have 4 y to the 7th over negative 3 y to the 5th.
Isn't that 4 y to the 2nd?
Yeah. 4 y to the 2nd over just negative 3.
Oh, that makes sense.
Okay, that was a really hard warm-up. So it's worth looking at one more time. Thanks for being so brave to come up and do that one. Let's try looking at it again. When you look at what Skylar did, she had a simpler warm-up. But remember, she had y to the 7th over y to the 5th here. And they were the same base, so she just subtracted the exponents to get y to the 2nd. Right? You can, even though she didn't do it first, right? Because you guys are still learning that, she worked them all out, and then we went, oh, we could have just subtracted exponents. So when you're down here, if you can get this simplified a little bit, so the 4, we figured out because there's no 2's in the denominator, but since we have 3's in both the numerator and the denominator, make that 4 times 3 to the 4th times y to the 7th. And then, like Sandra was saying, since this is an odd power, in the end we're going to get a negative value. So just put the negative outside and say 3 to the 5th times y to the 5th. Now we're back to that situation where we have the same base. So y to the 7th over y to the 5th. There's more y's in the numerator. So how many are going to be left in the numerator? 2, because we could subtract exponents there. So we just have y squared. Okay? And then we have 3's. We have 4 3's in the numerator and 5 in the denominator. So there's just going to be 1 in the denominator. We still have a negative, and we still have a 4 up there. And that's your final answer. You see that? So it's worth looking at twice. That's a super hard problem. I just wanted to push you a little bit today on that. You know, that's pretty darn hard. I would say it's harder than a test problem at this point. Yeah. But if you can learn to think about things like that, those test problems become much easier. Does that make sense? Okay. We're going to skip number 6. We'll talk about that in a minute in the new lesson. I was just trying to get you to preview the lesson. So, do we have any questions on the warm-ups? Yeah, Naive?
Should it be, that is going to be, so you subtract the 4 and the 5 to get.
Yes, you would have got, you could have, so another approach would have, you could have taken the exponents and subtracted them. You would have gotten the 3 to the negative 1, which puts the 3 in the denominator. It's harder to do it that way. So the question is, can I subtract the exponent 4 and 5?
So how did you get
The 3?
Yeah.
Because there's 4 3's in the numerator, so you have 3 times 3 times 3 times 3, and there's 5 3's in the denominator, like what Skylar was doing. So this one cancels with this one cancels with this one cancels with this one cancels with this, and you're left with 1 in the denominator. So the 3's in the denominator, and that's in the other, this 4 stays in the numerator. Okay?
Thanks.
Pretty hard. That was a hard problem. Okay, so today's going to seem easier. All right, let me make this a little bit bigger. So we're going to work on section 7.4 today, and there's some power rules. Oh, that space is so big. So here's some problems. We want to complete this rule in a minute, and take a look at these problems just using maybe some logical thinking. Okay? So, yeah, what do you know, Nadeef?
You go to problem.
I can blow up the problems. Better? You guys see that in the back?
Yeah.
Let me do that with all of this. So these are the examples we're going to look at today. They're much easier than that last warm-up, so you'll be fine. They get a little harder at the end, but I think not as hard as the warm-up. Okay, so just thinking about what an exponent means, we want to look at a problem like number 1 here, and consider this exponent 2, and it's really telling me what? What's that 2 telling me? Yes, it.
Whatever number is in parentheses, that number times itself.
Yeah, there's 2 sets of whatever's in parentheses. So this would be 2 to the 5th times 2 to the 5th. No. So what's the rule? Somebody new, Natalie? Same base, right, Harry? It's 2 to the 10th, right? Because if you go back to the warm-up today, whenever your base is the same, you just add the exponents. And if you're not sure, if you forget all those rules, think about this. 2 to the 5th is 2 times 2 times 2 times 2 times 2. And then this 2 to the 5th would be 2 times 2 times 2 times 2 times 2. Of course, you don't want to do that every time, but it's okay to do that once in a while to remember the rules. So your base is still 2 because there's a whole bunch of 2's here. There's 10 of them. So your exponent is 10. So you have the same base here. So you're adding the exponents. Yes, Skylar.
How'd you get to the 5th to the 5th?
Okay. the way I got that is this exponent's telling me there's two sets of these.
Oh.
Okay, yeah, it takes more than one strike in. Okay, does that make sense? Yeah.
Do the same, like, would there be like side effects if that's what it is?
Yeah, so let's look at problem 2. Did you hear his question? If there's 3 sets? So problem 2 says there's 3 sets of 3 to the second. So this is 3 to the second times 3 to the second times 3 to the second. And so that's 3 to the 6th power. So what if I had big numbers, big numbers, and what if I just slip one more example in here? Then I said, okay, you guys can do that. What if I had like 4 to the 5th to the 30th power? Are you going to want to write all that out, or can you jump to a conclusion? Yeah, Matthew.
So would you do 3 times 5? Do 4 times 5.
It's not 4 times 5 because there's 30 sets of 4 to the 5th power.
Oh.
So Cameron, hang on, Skylar.
So couldn't you like do 5 times 30?
Yeah. Is that what you're gonna say? Is that what you guys are gonna say? It's the same base, right? When you look back here, right? If our base was 2 in the beginning, our base was 2 in the end, right? Our base here was 3. In the end, our base is 3. So we know that our base has to be 4, but he's saying it's to the 3, I'm sorry, to the what? I multiplied wrong.
5 to 130.
To the 150th power.
Wow, that's a big number.
Right, so you don't want to draw out 154s, right? So let's go back and investigate that over here. What's 5 times 2, you guys? What's 5 times 2? 10, right? What's 3 times? What's 3 times? What's 3 times 2? 6, and there's it in your answer, right? So, Nadeem.
Can you have an exponent and an exponent?
Yes, this is basically that idea.
And 4 squared.
You don't see it much in middle school, even in the beginning of high school math, which you guys will be doing next year, but it starts to come up more and more. But this is basically, that's what this is, Nadeem, a power to a power. Okay, so what's the shortcut? What's the rule? How do we complete the rule? What is it, Cameron? So how would you write the rule? Like, can you figure out what to put here in terms of A, M, and N? How would you do that? I was gonna say N. A to the M times N. Do you guys see that? When you have one base and 2 exponents, you rewrite it as the base with the product of the exponents. Okay, Cameron.
If you had actual numbers like 7 to the second, out to the parentheses to the third, and if you wrote it like that, it goes 7 to the.
No, you could if it helps you put a little dot in between there, but whenever 2 letters are next to each other in algebra, the implication is you multiply. You just always multiply. But there's nothing wrong with putting a little dot there. Not even.
What if there weren't any credits?
It's very unclear to it's hard to read, so there will be parentheses until maybe you see a more sophisticated text, and then the exponent is even smaller, the second exponent, or higher, I should say. It's typed up higher. But you guys are going to see it with parentheses. See these problems with parentheses. Okay? So let's Let's everybody re-engage here. I feel like a few of you are kind of getting distracted. Let's think about how you would do problem 3 just using common sense. Because we're going to come up with a different rule. So the first rule was if you have one base and an exponent and then a second exponent outside, what's the rule? Now the question is when you have a product raised to an exponent, what is the rule? So Matthew.
For number 3, is it 12 times 12? 3 times 4 is 12.
It's true. It's 12 times 12. Let me ask you if you could write that without expanding the inside. Somebody do it with leaving exponents in the problem. Sean?
3 squared times 4 squared.
Yeah, did you guys hear him? It's 3 squared times 4 squared, because if we went the long way, which we only like to do when we're trying to find patterns, there's 2 sets of 3 times 4. So it's going to be 3 squared times 4 squared. And the reason I wanted to do that is because when you have variables up here, sometimes you can't multiply the inside. But you were right to begin with, Will. I could have said it's 144, but just to learn the pattern, we're going to stop here for right now. Okay, so take it a step farther, leaving exponents in the problem. Let's see, Noah, what would you do here at number 4?
Leaving exponents in the common. You do 2 times 4, 3 times 3, 2 times 4.
Okay, so 3 squared, that's yellow, sorry. So 3 squared times 4 cubed times 3 squared times 4 cubed, because there's 2 sets of these.
Yeah.
Right. So keep going now. Simplify a little more. So 3 to the 4th is how you say that. Times 4 to the 6th. Raise your hand if that makes sense. Are you okay on that? Okay. And the reason I wanted you to leave it like that is because when there's variables in the problem, you have to understand that. You have to kind of understand the rule. So maybe before we do 5, what's the rule that I can put right here? How can I complete that rule? Somebody I've heard from today. Or somebody new, guys. Take a chance. The rule, like in variables. David, you want to try? There's got to be an A in it, and a B in it, and an N in it. So what do you think the rule is?
A squared times B squared equals.
Whoa, I'm asking David. But the variable is N.
Oh, you're asking me?
I'm asking David. Do you guys hear him? Say it louder. A to the N power times B to the N power. Yeah, no, we're just thinking the simple kind of problem. That's Pythagorean theorem. Just because it's exponents, right? It's coming to mind. So let's go back and see if that makes sense. If I were going to see if that rule made sense, this exponent gets applied to both. That didn't work so well. This exponent gets applied to both parts of the product. So here, the answer would have just been 3 squared times 4 squared. Do you see that?
Yeah.
And Noah did that in pieces, but now you can say 3 squared to the second power is this times this is 3 to the 4th. And 3 times 2 gives us 4 to the 6th. So let's try to use that here. First we have to We're not really ready for this. Let's get rid of that. We'll do that on a different day. Okay, so let's try to just apply the rule without intermediate steps. Kareem, what would you do?
Do the exponents that are inside the parentheses.
Okay, so, but if you were using this rule, if you were using the rule,
But they already. So do you just double it?
let's go the long way one more. There is a little difference, isn't there? Can you see number 4, what we did though? Do you want to try?
Okay. So that could be 3 to the second. So
So you're going to look at these.
yeah. So it's 3 to the 6th power.
Good. Way to stick with that. 3 to the 6th power. And now you're going to look at these two together. X to the 9th. That's the whole thing. That's it. Yeah. Now, I can figure out 3 to the 6th power. You know, so I'll give specific directions if I want you to do that. But for just learning the rule today, let's just stick with leaving it in exponent form. Xander. No, that would be right. 4 to the negative 6th. Okay. There's 3 sets of the 3 too, though, right? Think of that Skylar's trick or her little thing she was doing. Put a 1 right here.
3 to the 3rd.
3 to the 3rd. X to the 9th. Okay, what if I said you can't have negative exponents? You could, where would this go?
4 to the 6th because it's a even.
What's a negative exponent mean?
Oh, yeah.
Adam.
Make it smaller so you turn it into like a fraction.
Yeah, you make it a fraction, right? So the final answer would be 3 to the 3rd, but you'd have it multiplied by 1 over 4 to the 6th. So really that's in the denominator, x to the 9th. So you're going to have x to the 9th, 3 to the 3rd, sorry, times x to the 9th over 4 to the 6th. Okay, so let's talk about your situation. This is a super hard problem in the homework. The rest of them, I would say, is about homework level problems. This is a little bit above and beyond here. So I'm going to give you a practice test tomorrow, and that'll answer some of those questions. Adam. Because a negative exponent is a reciprocal, which makes the 4 to the 6 go to the denominator.
Yeah.
So you could think of this as 3 over 1 when you multiply fractions. You multiply the numerators, so you have 3 to the 3rd in the numerator and 4 to the 6th in the denominator.
Okay.
So that's why I said this is kind of a bonus level. We'll practice more with that. And you don't have to have that one mastered. But everything else, the other 5 examples, those are about what the level of the homework is. Okay, Ian? Okay, that was a good question. He asked if I would write this as 27 over here instead of 3 to the 3rd. So if I asked you to simplify completely, I would end up expecting this, and then 4 to the 6th. But on a test, 4 to the 6th is pretty hard to do without a calculator. So that's why once the exponents get pretty high, it's also sometimes acceptable to leave them in exponent form. So the answer is it depends. And when I give you a test, I will make sure I clarify. So if we look at the homework tonight and the exponents are small, any exponents that you can calculate in your head, you should simplify. Okay, and then if there's any confusion, after we go through the homework, we'll clarify that. So 4 to the 6 is what? What is it? Okay, let's check it. So we're going to go 4. So that would be a lot to expect on a test without a calculator, 4,096. And so Cameron was right. That's why I didn't do that, Ian. As exponents get bigger, the standard is that you leave it in exponent form. Okay. Pardon me? Did you? Oh, I know you can do it, but I'm not sure that I would want you to waste time doing that on a test when I might want you to be thinking about other things.